This is one of a series of videos on how to develop nonfiction technical writing skills in science class. Today's topic is how English as a second language, English language learner support builds literacy for all science students. Helping ELL students communicate science involves two things: showing what content to share and showing how to effectively express that content in English. Many studies show that the same moves that help ELL students practice and master appropriate English expressions also help all students improve their effectiveness when they write about science. The methods section of a report, a lab report or a science fair project, for example, illustrates these shared benefits. Everyone needs to learn what a typical methods section contains, for example, sequences observed or procedures followed. But ELLs also need to learn how to put that into words effectively. Some technical writing books take on both goals together, such as Hilary Glassman-Deal's Science Research Writing for Non-Native Speakers of English. Glassman-Deal spells out the 8 stages of a technical sequence, a distinction almost invisible to fluent English speakers, but challenging for ELLs or for any student with weak literacy skills. Let's step through these 8 stages linguistically. Kitchen recipes offer a comfortable way to teach these sequence distinctions. Recipes combine topic familiarity, food, with procedural challenge, language. So let's step through one typical recipe for chicken parmesan and use that to spell out the English sequence words best suited to signal each step. Stage 1 is preparation, before the beginning. One common English signal here is in advance. Gather all ingredients in advance. Stage 2 is at the beginning, where the sequence steps actually start. The normal English signal word here is first. First, add the breadcrumbs and olive oil to a large pan. Stage 3 of a sequence involves executing the actual steps. Next and then are common English signals for successive steps. Next, mix the flour and seasonings. Then, mix the cheese and cooked breadcrumbs. Often, long sets of steps cluster into phases. Stage 4 is the early phase. Before often signals this stage. Before coating the chicken, arrange the dishes in order of use. Stage 5 is a later cluster of related steps, a later phase. After signals that this stage follows the earlier one. After arranging the coatings, dredge each chicken piece in flour, dip in the egg, and press into the breadcrumbs. Some sequences involve a stage 6, when several steps happen at the same time. While signals such simultaneous steps. Preheat the oven to 350 while you prepare the chicken. Stage 7 marks the end of the sequence. Finally, indicates that the next step is also the last one. Finally, bake the coated chicken for 15 to 18 minutes. Stage 8 falls at the end of the sequence as a procedural postscript. Afterwards indicates such wrap-up steps. Afterwards, top the baked chicken with tomato sauce and cheese. So this linguistically enhanced walk through a recipe, or through any science sequence, shows students both the key steps on the left side of the chart and the way to express those steps effectively on the right. This is one of a set of ESL/ELL support moves that benefit all students, that sharpen everyone's technical communication skills. A second case of overlap between ELL support and general literacy improvement is managing other text signals, especially those crucial conjunctions and connectives. For instance, to assert both that blood contains erythrocytes and that blood contains leukocytes, you can use several logically equivalent English conjunctions, and, also, furthermore, but. If these words are not completely interchangeable, you can point out to your students both their logical overlap and their semantic differences. A third case of benefiting all your students by deploying ELL support is understanding science idioms, those English phrases whose net meaning does not follow from understanding their components. Turning something into little pieces can be expressed using several different verbs. Break up, an idiom, actually has no vertical direction. You have to learn independently from understanding its components that it really means crush or decompose. Pointing this out helps all students choose words carefully to meet the needs of their international audience. There are many other similar linguistic challenges in science communication, using lists, giving examples, making comparisons. Alerting students to the specific terms and patterns that work well in each case helps ELL succeed and helps all students improve in writing about science effectively so that others can understand them. For more background on and examples of how technical writing supports ELLs in science class, use this URL.